So here is the integral of 5x e to the 3x dx. Again, we want to think u substitution first. This would be our inside function here. But its derivative is not all that's here. Its derivative is just 3. Well, okay, I don't have to worry about the coefficients. I could always fix the coefficient, but then I'm stuck with this x. And that is not going to be helpful. I'm not going to have any way to get rid of that x and turn it into a u to allow me to do the u substitution. So we need to try something else. What we can do is see if integration by parts will work here. We need to look at our two factors, 5x and e to the 3x. We're going to look and see if one of them can get simpler when we differentiate it. Well, that looks enough. 5x kind of fits that description. We'll be able to differentiate that. It'll get a lot simpler. And another part has to be easy to integrate. Well, e to the 3x is easy to integrate, so that can be our dv. I know in the videos you saw yesterday, they put the dv down here. And like they went to this direction. I'm going to suggest that you don't do it that way and you do it down, because it'll help us in our other examples today, and well, more so next class. So I will take my u, I will differentiate the u, find the differential of 5x. Well, that's 5 dx. Because remember, du dx is 5. I just move the dx over. And then v would be the integral of e to the 3x. And I apologize, I shouldn't be writing e to the 3x. The other factor here is e to the 3x dx. Because if we're going to integrate, we need to have the dx there. And so we're taking the integral of e to the 3x dx. Luckily, that one was easy to integrate. That's why we chose it. It's easy to integrate an exponential, or at least an e to the x. It's just itself. The antiderivative of e is itself. Of course, because of the simple chain rule, we've got to remember to divide by 3. But that's no biggie. And so now we can apply our formula. The integral, and remember the formula is up here on the top right. The integral of u dv, so I'm going to write that out here. My u is 5x. My dv is e to the 3x dx is equal to uv, that's 5x e to the 3x over 3. I just took the u and the v and I multiply them together. Minus the integral of v du. That would be 5/3 e to the 3x dx. Notice how I reordered the pieces. The 5 dx, I kind of split them up so I could have my dx at the end. And the e to the 3x over 3, I split them up so I could kind of separate my coefficient from my function. But I'm allowed to do that with products. And the advantage here is now we have an integral that is easy to integrate because we've simplified the 5x. When we differentiated it, we made it into something easier. So now we don't have to worry about impossible integrals anymore. So we can write this as 5x e to the 3x over 3 minus the antiderivative of 5/3 e to the 3x is 5/3 e to the 3x, again, over 3 because of the simple chain rule. So I'm going to write that as 5/9 e to the 3x plus c. And that's my final answer. Some of you who are watching this may have had the clever question of, well, how come I didn't need a plus c here when I took the antiderivative of dv? The truth is I did have a plus c there, but I also knew that I was going to be ending up with an integral leading to another plus c, and I don't need to add a c twice because they would just combine to make some other unknown constant, so I just saved it for the end.